Okay, in this lesson, we're going to be taking a look at multiplying binomials. These are called binomials because you have these two terms in here that makes this first one. So this is a binomial times a binomial. These are another examples. Of course, this is x minus 2 squared, which just means x minus 2 times x minus 2. So again, we are multiplying binomials in this one. So previously, we have looked at multiplying using the distributive property to multiply these polynomials. But in this first one here on the left, we have one term on the outside of the parentheses and then these three terms on the inside. And then on this second one over here, it's different because we just have the two terms inside the parentheses times another one inside the parentheses. But we're going to continue the distributive property. So you can see here in this diagram that in either one of these that we're multiplying these polynomials, we're using the distributive property. But very specifically in this binomial, you'll see it's a little bit different because we don't have one term to multiply by the others, but we have two terms to multiply by the other two terms. Okay, so we're going to use this strategy, and that's what we're going to do in this video. All right, so let's just take a look at this example to use, and I'll show you how this works. So in example 1, we have 2x plus 4 times 3x minus 5. So what we're going to do basically is we're going to multiply both of these two terms times these two terms. Okay, so we're going to start with this 2x, and we're going to multiply it times 3x, and then we're going to multiply the 2x times negative 5. Then we're going to come to the 4 and multiply it times 3x, and then multiply 4 times negative 5. So here's what that looks like. So let's start with 2x times 3x. Now, 2 times 3 is just 6. All right, so we have a 6, but we also have the x squared, okay? So remember that an x to the 1 power times an x to the 1 power, we add those two ones and we get the 2. So that's 6x squared, okay? Now we're going to multiply 2x times this term, which is a negative 5. Well, 2 times negative 5 is negative 10. Then, of course, we have this x. So now what we have is a minus 10x. Okay, now I'm going to go to the 4. Okay, I'll multiply both of these times 2x, but now I have to multiply the 4 times the 3x and the minus 5. So 4 times 3x, 4 times 3 is 12, and then we have the x, so that's plus 12x. Now we have 4 times negative 5, which is negative 20, or we write minus 20. All right. Well, now you see that you have these 4 terms, but these two terms in the middle, this minus 10x and plus 12x, well, these are like terms because it's the same variable and the same exponent of 1. So we can just combine these like terms. Well, a negative 10x plus 12x gives us a positive 2x. So that term is going to become 2x, and that's a positive 2x. So plus 2x, well, we just bring down our 6x squared plus 2x, and then, of course, at the end, we have our minus 20. Okay, so this trinomial is now what we got when we multiplied these two binomials. This is the product of this multiplication problem. Okay, let's do another example. Okay, so x plus 4 times 3x minus 2. Remember, we're using the distributive property. So this is 1x times 3x. And 1x times 3x, well, 1 times 3 is 3, and x times x is x squared. So 3x squared. Then on the outside, we have 1x times negative 2. Well, 1 times negative 2 is negative 2, and of course that's an x, negative 2x. Okay, then we come to the 4, and we multiply 4 times 3x, which is a positive 12x. And then we have a 4 times negative 2, which is minus 8. All right, well, we know that we have the 3x squared, okay, but we're going to combine these like terms of negative 2x plus 12x, that gives us a positive 10x. So plus 10x. And then finally we have our minus 8. All right. So again, that is what it looks like to multiply a binomial times a binomial. Now I want to show you also real quick when we talk about area of shapes. Okay, you know how to find the area of a rectangle, or you know how to find the area of a square, but I want to show you how that can be represented with binomials, okay, or polynomials. So let's say, remember, we need to find the length times the width to find the area of a rectangle. Well, if you're told that this measurement is 2x plus 5, and that the width is 3x minus 2, if you wanted to represent the area of this rectangle, it's simply 2x plus 5 times 3x minus 2. So again, we just have the length, 2x plus 5, and then times the width, 3x minus 2. Okay, so this term, or this binomial times binomial, represents the area of this rectangle. And then if we went ahead and solved this, then we would know the actual area of this rectangle based on these binomials. Now, this other one here is a little more specific. It is a square, okay? So in a square, if you're showed that one of the measurements is 3x plus 4, well, a way to represent the area of this rectangle then is just to say 3x plus 4, and then we could put that in parentheses and say it's squared. Because remember, this 3x plus 4 squared just means 3x plus 4 times itself. So 3x plus 4 times 3x plus 4, which is how you find the area of a square. So if you see a problem like this, 3x plus 4 and it's squared, you don't just square 3x and then square the 4. You actually have to write it out. Just think about writing it out. 3x plus 4 times 3x plus 4. Okay, and that's our lesson on binomials.